So what I'm going to do now is just show you a demo of Creo Simulation Live. So if you're familiar with Creo here, you can see this is an assembly. We've got a number of different parts that contribute to this model. If we've installed live simulation when we've installed Creo, and probably we have, if we click on this button here, it will take us through to the live simulation tab. If you don't have a license of this, ordinarily it would throw up an error or invite you to do a trial perhaps. But I guess what we see now is the model tree changes. We've got the simulation studies shown there, and if I just expand these, you can see this model has actually already been created. In a moment, I'll go back and show you the other how we set up a model. But in this case, we've got a displacement constraint. If I just quickly show you that, we've got this free along the X direction, so it's allowed to move in that direction. It's fixed along, moving from up that way and into the plane as well. Okay, so the cylindrical connections are at the other end. If I just look at that, we've now got that, it's basically rotating around, and it's also free to move along that direction, which will allow that geometry in that particular region to not be, artificially constrained effectively. Okay, then we've got a couple of forces which are added, both on one on each side, the same force added there. All right, so whenever I'm ready, I can just press the simulate button, which I just did quickly there, and you can, if you look closely, you can see that this value here is sort of updating in real time. Okay, it's not going to change too much more than 99 by the looks, but as it goes away and works out its solution, we get that. Okay, so inside this window, we can then add, there's a little button here which we can say show the maximum and minimum. So if I look at here, we've got a red circle, which is indicating to me that's where the maximum stress is of 99, and the minimum stress is where this is up here. Okay, so there's effectively no, if you look at that value, effectively no stress there. All right, so we can also look at the deform shape. So if I just click animate deformation, I'll try and slow this down because it might not work that well over a screen sharing session, but you can see based on that load pushing that direction, this pin was allowed to move in a particular direction. Okay, that's the resulting values that we get. In this case, it's showing the maximum deformation. So the maximum distance that a particular point on the entity moves is actually in this region, as you can see what's happening there if we view it from that direction. Okay. I'll also in this model as well show you that there is this deviation option, which this if I look closely shows you areas where potentially there might be some slight errors, and typically it occurs like on edges or interfaces between components. There's a long-winded explanation on how the meshing and that works in this particular model, and in models in general. But I would also say there is a performance option here, which you can actually set that would allow you to gain more accuracy. I won't do that now, but if I was to, I could rerun the analysis and get a more potentially a more accurate result into the real world. It would take longer. Also with this, this is done purely by the GPU. So the better the GPU you have, the faster it can happen, and also the more accurate your results become. Okay. All right, so moving on now, we'll just go over looking how to create a single part to run an analysis on that. So I might be looking at, you know, okay, is this design efficient or not? So what I might do is I'm going to say, firstly, I'm going to put a force on here. That force is, if I look at my little triad down the bottom, so I'll say in the Y direction, sorry, so in the Y direction of, let's say, 5 newtons, okay? So I put that on, actually it's in the wrong direction, right? So if I want to swap that around, I can just say -5, okay? So that's pretty easy. As far as constraints go, we just need to represent that, how it's going to hold in the real world. I could use just a fixed constraint on the back. I'll probably try and do it a little bit better than that. I'll put a planar constraint on the back, and I'll put a cylindrical connection on there. This is allowing that to translate along its axis, but the other planar connection we've got there we'll be stopping that anyway, and I'm just adding these in one at a time quickly as I'm talking here, okay? So at that point, really, we're ready to simulate. Now, in this case, it's taking the material properties from the model, so I haven't there's no real definition of material in here, but it's taking that result from the material definition in the model. So I guess the real point of this is if I was to change something, so in this extrude here, if I'm to edit, let's say the width, let's make it 5, okay? As I commit that change, the analysis starts again, and now we can see the stress changes, okay? I didn't show you the value before, but you can see now it's 16. If I just undo my change, okay, it goes to 27. If I redo my change, it comes back to 16. And so you can see how quickly and easily that we can make those changes and get some feedback about whether or not that's sufficient. And of course here we could, if our criteria was based on deformation and we wanted it less than a certain number of millimeters, then we have the ability to choose that and use that as our guide as well.